Welcome to Spring LIB.
So here we want to determine the force, and we can say that here, um, for part A, we know that the work is going to equal the force times distance times cosine of theta. In this case, theta is going to equal 0 degrees, so this term is going to be equal to 1, and this would equal the change in kinetic energy. We know that solving for the force is going to be equal to the change in kinetic energy divided by the distance, and this will be equal to 1/2 times the mass times final velocity squared minus initial velocity squared divided by, again, the distance. And we know that the initial velocity is going to be 0. So here, the force is going to be equal to 1/2 times the mass of 0.033 kilograms times 85 meters per second quantity squared divided by d, the distance of 0.32 meters, and we find that the force is equaling 372.5 newtons. And then part B asks us to find it in a different way. So for part B, we can simply say that the force is equal to the mass times the acceleration. So this will simply be equal to m v final squared minus v initial squared over 2 times delta x. So here we use the work equation in order to find the force, but here we simply use kinematics in order to plug in for a constant acceleration and solve for force using kinematics instead. So force is going to be equal to the mass of 0.033 kilograms times 85 meters per second squared, or rather meters per second quantity squared, and then divided by, again, 2 times 0.32. And of course, it's equaling the exact same answer of 372.5 newtons. That would be our final answer. That is the end of the solution. Thank you for watching.